Our solar system, a cosmic ballet of 8 major planets and countless smaller celestial objects, all engaged in a delicate gravitational dance. But what if, in a cosmic blink of an eye, one of these dancers were to vanish? Imagine a planet simply gone, removed from the equation. What would happen? Would the solar system descend into chaos, planets careening off in new directions? Or would the change be more subtle, a cosmic ripple rather than a tidal wave? Today we're going to explore these questions, examining the potential consequences of removing each planet from our solar system one by one. Mercury, the smallest of our 8 planets and the closest to the Sun, is a world of extremes. Scorched by day, frigid by night, it races around the Sun every 88 Earth days. Mercury's gravity, while weak, does influence the Sun and other planets, particularly Venus. Its absence could lead to subtle shifts in Venus's orbit, potentially affecting its climate over very long timescales. More importantly, Mercury acts as a gravitational shield, absorbing and deflecting some of the solar wind and space debris constantly streaming from the Sun. Without Mercury, this cosmic debris would have a clearer path to Venus, Earth, and even Mars, increasing the chances of impacts. While the immediate effects of Mercury's disappearance wouldn't be catastrophic, the long-term consequences could be significant. Venus, our closest planetary neighbor and often referred to as Earth's twin due to its similar size and composition, is a world of scorching temperatures and crushing atmospheric pressure. It's a stark reminder that appearances can be deceiving. Now imagine a scenario where Venus, this celestial inferno, suddenly vanishes. Venus exerts a strong gravitational pull on Earth, influencing our planet's orbital dynamics and even contributing to the slight wobble in Earth's axis of rotation. Without Venus, this gravitational influence would disappear, potentially leading to subtle changes in Earth's axial tilt and orbital path. While these changes wouldn't be drastic enough to fling us out of the solar system, they could impact Earth's long-term climate patterns. Furthermore, Venus acts as a gravitational shield for Earth, deflecting some asteroids and comets that might otherwise pose a threat. While the loss of Venus wouldn't be an immediate apocalypse for Earth, it would be a significant event with long-term consequences for our planet's climate and overall safety. What if our home, our pale blue dot, Earth, suddenly blinked out of existence? It's a thought experiment with a hint of existential dread, but it highlights just how interconnected our solar system truly is. The most immediate and obvious consequence wouldn't be on the other planets, but on our faithful companion, the Moon. No longer tethered by Earth's gravity, the Moon would become a rogue celestial body, likely pulled towards the Sun's gravitational embrace. But what about the other planets? Would they even notice our absence? In the grand scheme of things, Earth is a relatively small planet. Its gravitational influence on the rest of the solar system is dwarfed by giants like Jupiter and Saturn. However, our absence might be felt most keenly in the asteroid belt, that chaotic region between Mars and Jupiter. Without us, the gravitational balance could be disrupted, potentially sending some of these space rocks hurtling towards the inner solar system, posing a greater threat to the remaining planets. Mars, the red planet, has captivated our imaginations for centuries. Its rusty hues and potential for harboring past life have made it a prime target for exploration and even future colonization. But what if, in a cosmic twist of fate, Mars were to vanish? The most immediate consequence, of course, would be the abrupt halt to our Martian ambitions. No more rovers trundling across its surface, no more dreams of one day setting foot on its alien soil. But what about Mars's impact on the rest of the solar system? Like Earth, Mars is a relatively small player in the cosmic gravitational tug-of-war. Its disappearance wouldn't drastically alter the orbits of the other planets. However, Mars does play a role in shaping the asteroid belt, that cosmic shooting gallery between itself and Jupiter. Without Mars's gravitational influence, the asteroid belt could become slightly more unstable. Jupiter, the largest planet in our solar system, is a true behemoth. A gas giant with a mass greater than all the other planets combined. Its gravitational influence is so immense that it's often referred to as the protector of the inner solar system. But what if this cosmic guardian were to disappear? The consequences would be profound and far-reaching. Jupiter acts as a gravitational vacuum cleaner, attracting and absorbing countless comets and asteroids that would otherwise pose a threat to the inner solar system, including Earth. Without Jupiter's protective presence, these cosmic projectiles would have a clear shot at the inner planets, significantly increasing the risk of catastrophic impacts. Furthermore, Jupiter's gravity plays a crucial role in shaping the asteroid belt, keeping it relatively contained and preventing it from scattering. With Jupiter gone, the asteroid belt would become a chaotic and unpredictable region. Saturn, the ring jewel of our solar system, is a sight to behold. Its magnificent rings, composed of countless ice and rock particles, are not just a beautiful spectacle but also a testament to the planet's powerful gravitational influence. But what if Saturn, rings and all, were to suddenly vanish? While Saturn might not be as massive as Jupiter, its disappearance would still send shockwaves throughout the solar system. Like Jupiter, Saturn acts as a gravitational shepherd, guiding and containing the asteroid belt and preventing it from scattering. Without Saturn's influence, the asteroid belt would become more susceptible to gravitational perturbations from Jupiter and the inner planets, increasing the chances of asteroids being flung towards the inner solar system. Saturn's disappearance would also have a significant impact on its moons. Without the planet's gravitational anchor, these moons would become like lost ships on a cosmic sea. Furthermore, Saturn's gravity plays a subtle but essential role in the long-term stability of the outer solar system. Uranus, the ice giant tilted on its side, might seem like a distant and insignificant player in the grand scheme of the solar system, but even this icy world, shrouded in methane clouds, plays a role in the delicate gravitational ballet that keeps our cosmic neighborhood in balance. While Uranus's disappearance wouldn't have the same dramatic consequences as the loss of Jupiter or Saturn, it would still be felt throughout the outer solar system. Uranus's gravity, along with Neptune, helps to shape and stabilize the Kuiper Belt, a vast and distant region beyond Neptune that's home to countless icy bodies, including Pluto. Without Uranus's influence, the Kuiper Belt could become more dynamically active, potentially sending more comets hurtling towards the inner solar system. The loss of Uranus could also impact the orbits of its neighboring gas giants, particularly Neptune. Neptune, the farthest planet from our Sun, might seem like a lonely sentinel at the edge of our solar system. But even this distant ice giant, shrouded in azure hues, plays a crucial role in maintaining the delicate balance of our cosmic neighborhood. Neptune's gravity, along with its neighbor Uranus, helps to shape and sculpt the Kuiper Belt, a vast and distant region beyond Neptune that's home to countless icy bodies, including dwarf planets like Pluto. Without Neptune's gravitational influence, the Kuiper Belt could become more dynamically active, potentially sending more comets hurtling inwards towards the Sun and the inner planets. The loss of Neptune could also have implications for the search for Planet 9, a hypothetical planet thought to exist beyond the Kuiper Belt. While Neptune's absence wouldn't have the same immediate and dramatic consequences as the loss of Jupiter or Saturn, it would still be a significant event with long-term implications for the outer solar system. As we've journeyed through our solar system, contemplating the hypothetical disappearance of each planet, one resounding theme emerges: interconnectedness. The planets aren't isolated islands in a vast cosmic sea. They're engaged in a delicate gravitational dance, each one influencing the others in ways we're still unraveling. The loss of even the smallest planet, like Mercury, could have ripple effects that resonate throughout the solar system, potentially impacting the orbits of other planets, the asteroid belt, and even the flow of space debris. Our solar system is a symphony of gravity, a delicate balance of push and pull that has persisted for billions of years. It's a humbling reminder of the interconnectedness of our cosmic neighborhood and the delicate balance that sustains it. So the next time you gaze up at the night sky, consider the intricate cosmic dance playing out above. Each point of light, each planet, each asteroid plays a role, no matter how small. The universe is full of surprises, and while we can't predict when or how the next cosmic event might unfold, we can appreciate the delicate balance that holds our solar system together. It's a reminder that we are all part of something much grander than ourselves, a cosmic tapestry woven together by the threads of gravity and time.